welcome to the channel. The purpose of channel is to facilitate students in learning physics at their convenience. It is a class without a classroom, so learn physics at your convenience. Let us start our today's lesson. The topic is capacitors in series. Students, you know that sometime in electrical circuits we need more than one capacitors and we connect them either in series or in parallel. Today we will discuss how the capacitors are connected in series. If in a circuit capacitors are connected one after the other as shown in the diagram, the combination is called series combination. Let three capacitors of capacitances C1, C2 and C3 are connected one after the other across a voltage source or a battery of voltage V. Students, in this diagram, look at the situation. Let a positive charge moves from positive plate of the battery towards the left plate of first capacitor C1. Since there is insulator in between the two plates, so charge will start depositing on this plate. Due to electrostatic induction, a same amount of negative charge it will attract on the other plate or on the right plate of capacitor C1. And a same amount of positive charge is repelled toward the left plate of capacitor C2. Similarly, due to electrostatic induction, same amount of negative charge will deposit on the right plate of capacitor C2 and the same amount of plus charge is pushed away towards the left plate of capacitor C3, and finally the right plate of capacitor C3 will have same amount of negative charge. In this way, left plates of all the capacitors will be positively charged and right plates of all the capacitor will be negatively charged. Or in other words, when a negative charge moves from negative plate of the negative terminal of the battery towards the right plate of capacitor C3, there will be a same amount of positive charge on the left plate and so on. So we can say that in case of series combination, important point is that all the capacitor will equally charged. Now their capacitances are different, so the potential difference across the plates of the capacitors will be different. Let V1 is the voltage across the capacitor C1, V2 is the voltage across the capacitor C2 and V3 is the voltage across the capacitor C3. So sum of all these voltages is equal to the total voltage of the source. Mathematically, we can write total voltage V is equal to V1 plus V2 plus V3. Sum of all the voltages of the capacitors is equal to the total voltage or voltage of the battery. From the equation of capacitor, that shows that Q, the charge on the capacitor, is the product of its capacitance and potential difference across it. Number one, and number two, since from this equation we can get V equals to Q by C. So replacing V with its value Q by C, and further, since all the charge on all the capacitors are same, so we represent the charge with Q. Instead of representing Q1, Q2, Q3 for C1, C2, C3, we just write Q for all the capacitors because they are equally charged. So this equation gets this form: Q by C equivalent means total charge divided by total capacitance is equals to charge on the first capacitor divided by its capacitance plus charge on the second capacitor divided by its capacitance plus charge on third capacitor divided by its capacitance. Now taking Q common on the right side, we have taken Q common on the right side. This Q will be cancelled with the value of Q on the left side and we are left with this equation: 1 over C equivalent equals to 1 over C1 plus 1 over C2 plus 1 over C3. Students, it is the equation that we use for calculating the total capacitance of circuit in which capacitors are connected in series. The equation shows that in series circuit the total capacitance decreases, means the value of total capacitance will be less than the value of smallest capacitor connected in the circuit. So if we are having some capacitors of large value and we need a capacitor of small value, we will connect the capacitors in series. So this is all about the series combination of capacitors. I hope it is clear, students. Thank you for sparing your time to watch this short video. If you liked it, don't forget to subscribe the channel. Take care of you. Goodbye.